Welcome to 6.3 Solving Trigonometric Equations Part 2. We're going to start this section with an example of an application. This is more indicative of what you might see as an application. It's not quite so straightforward. So what we're going to be looking at in 6.3 is when we have different inputs into our trig functions, and that is very common for applications. So let's take a look. The following function approximates average monthly temperature Y in Fahrenheit in Vancouver, Canada. Here, X represents the month, where X equals 1 corresponds to January, X equals 2 corresponds to February, and so on. Y equals 14 sine of pi over 6 times the quantity X minus 4 plus 50. So A is asking, what is the average monthly temperature in March? So notice that X is the month number and they gave us March. So January, February, March, X equals 3. So now we just need to evaluate this equation when X equals 3. Plugging in X equals 3, we get Y equals 14 sine of pi over 6 times 3 minus 4, and then add 50. So inside the parentheses, we get 3 minus 4 is negative 1. When we multiply that by pi over 6, we get negative pi over 6. So we need to calculate what is sine of negative pi over 6. So that will be in quadrant 4, and the reference angle is 30 degrees, so sine of negative pi over 6 is negative 1/2. So we get 14 times negative 1/2 plus 50, or negative 7 plus 50, because half of 14 is 7, and a negative times a positive gives us that negative. So we get 43, and remember, Y is our temperature in Fahrenheit, so we get 43 degrees Fahrenheit. This would be a great time to push pause and try B on your own. So now we're looking for the average temperature in April. So January, February, March, April, we get X is 4. So Y equals 14 sine of pi over 6 times 4 minus 4 plus 50. 4 minus 4 is 0. Pi over 6 times 0 is 0. So we get 14 sine 0 plus 50. Off to the side, the angle 0 gives us the coordinates 1, 0, and the Y value, or the sine value, is 0. So sine of 0 is 0. So 14 times 0 plus 50, or 0 plus 50, gives us 50 degrees Fahrenheit. And that does make sense that we would expect colder average temperatures in March than in April, considering that Vancouver is in the northern hemisphere. Now C. When is the average monthly temperature 64 degrees Fahrenheit? So now they're giving us the temperature, which is the Y. So we're going to plug in Y equals 64. So we get 64 equals 14 sine pi over 6 times X minus 4 plus 50. We're going to first subtract over the 50. So we get 14 equals 14 sine of that quantity. Then we will divide both sides by 14. So we end up getting 1 equals sine of that quantity. So we're going to go ahead and draw a picture for this angle. So that angle inside the parentheses is actually what we're going to be drawing a picture for. So where is this angle going to have a sine value of 1? So here, that's up at pi over 2. So what that means is our angle will equal pi over 2. So we now can say pi over 6 times that quantity, X minus 4, will equal pi over 2. There's a number of ways to solve this, but I will go ahead and multiply by the reciprocal of pi over 6 so that I'm just left with the X minus 4 on the left. x minus 4. On the right, the pi's cancel, and then we get 6 over 2, or just 3. Adding 4 to both sides, we get x equals 7. So now the 7th month is July. So July will have an average monthly temperature of 64 degrees. Go ahead and try D on your own. So now we have y equals 50, since y is the temperature. Subtracting the 50 over gets us 0 on the left. Dividing both sides by 14 still gives us 0 equals sign of that quantity, pi over 6 times x minus 4. I'm drawing a picture for this inner quantity, pi over 6 times x minus 4. Where is this going to have a sign of 0? So that's going to occur at 0 and pi. So that means our angle will equal 0 or pi. So we get pi over 6 times that quantity x minus 4 equals 0, or pi over 6 times that quantity x minus 4 equals pi. So I will go ahead and solve these kind of both at the same time. We're going to first multiply by the reciprocal of pi over 6. So I multiply both sides of both equations by 6 over pi. On the left, I get x minus 4 equals 0, or x equals 4. On the right, I get x minus 4 equals 6, or adding 4, I get x equals 10. So the 4th month is April, and the 10th month is October. So in this situation, we actually have 2 months out of the year that have the average monthly temperature of 50 degrees. Those are April and October. Example 1, solve 2 cosine of x over 2 minus rad 2 equals 0. A over the interval 0 to 2 pi, and B for all solutions. So take a look here. Notice we have the cosine of x over 2, but there are no other cosine x's. In this situation, anytime we have a cosine with a different input, but that's the only input to all of our trig functions, we're going to go ahead and leave this and solve for cosine of x over 2. So first we will add rad 2 to both sides. So we get 2 cosine x over 2 equals rad 2. Now divide both sides by 2 for this 2 out here. Since this 2 is multiplying by the cosine, we can divide both sides by 2, and we get cosine of x over 2 equals rad 2 over 2. So now we're going to do something a little different. We are going to draw a picture, but not for the angle x. We're actually going to draw a picture for the angle x over 2. So cosine is going to be positive in quadrants 1 and 4. And the reference angle will be a 45-degree angle, or a pi over 4 since we're in radians. So that means our 2 angles are going to be pi over 4, and this is 7 pi over 4. But when we go to write out what is that angle, it's x over 2 is the angle, because this picture is for that angle x over 2. So x over 2 can equal pi over 4, or x over 2 could be 7 pi over 4. Now we go ahead and solve for x. So we're going to multiply both sides by 2. So our final answer is x equals, we get 2 pi over 4, or reduce it to pi over 2, or x equals 7 pi over 2. So we remember for part A, we need to only give our solutions from 0 to 2 pi. So what we have to do is we have to make sure that both of these solutions that we came up with were actually 0 to 2 pi. So pi over 2 is right here, but if we think of 7/2, that's the same as 3.5. So 7 pi over 2 is actually 3.5 pi. So for part A, we will not list this solution. It is a solution. It's just not in the interval from 0 to 2 pi. So for part A, our solution is just x equals pi over 2, and that's it. Now for part B, for all solutions, remember we have to add integer multiples of our period. So we now need to calculate what is the period of cosine of x over 2. Recall that our period is 2 pi over b, where b is the number in front of x. So our period is actually 2 pi over a half, or 2 pi, flip it, times 2 over 1, or 4 pi. So instead of adding 2 pi n, we are going to be adding 4 pi n. We need to go back to our original solutions of pi over 2 plus 4 pi n and 7 pi over 2 plus 4 pi n, where n is an integer. Notice that pi over 2 and 7 pi over 2 are not 4 pi n away from each other. So it's imperative that we take all solutions and add the period times n. However, we don't list both of the solutions in part A because just for this one situation, we were limited to 0 to 2 pi. However, for all solutions, there is no limitation. Let's take a look at the practice. Solve the equation 2 rad 3 sine of x over 2 equals 3, a over the interval 0 to 2 pi, and b for all solutions. This would be a great time to push pause and try this on your own. Again, because we only have one input into a trig function of x over 2, and this is linear in form, we will isolate that sine of x over 2. So I need to divide both sides by 2 rad 3. So off to the side, let's simplify that. 3 over 2 rad 3. We need to rationalize the denominator, so we multiply top and bottom by rad 3. And we get 3 rad 3 over 2 times, this ends up being rad 9, or just 3. And we can see here, these 3's cancel, and we're left with rad 3 over 2. So we get sine of x over 2 equals rad 3 over 2. So let's take a look. We're now going to draw a picture. Again, our picture is going to be for the angle x over 2. Sine is positive in quadrants 1 and 2. And if the sine value is rad 3 over 2, that means the y value has to be bigger in the 30 or 60. So that's going to be a reference angle of pi over 3. So in quadrant 1, our angle is pi over 3, but in quadrant 2, our angle is 2 pi over 3. So when we go to write this out, we're not going to say x equals pi over 3 and x equals 2 pi over 3 because this is the picture for x over 2. So our equations will be x over 2 equals pi over 3, or x over 2 equals 2 pi over 3. To solve this, we multiply both sides by 2. So on this one, we get 2 pi over 3. And when we multiply this equation both by 2, we get 4 pi over 3. So 2 pi over 3 and 4 pi over 3 are both in the interval from 0 to 2 pi. So we can list both of those answers in this situation. For part B, we still need to calculate the period of sine of x over 2. So the period is going to be 2 pi over b, or 2 pi over a half again, or 4 pi, just like we got in this calculation. Therefore, our solutions are 2 pi over 3 plus 4 pi n, and 4 pi over 3 plus 4 pi n, where n is an integer. I hope you enjoyed this video. See you next time.